Good morning again. So now the next session, which is about the filtration process, we're going to talk in briefly about the multimedia filtration, activated carbon filtration, green sand filtration, and the cartridge filtration. So they're all at the end. They do a good filtration process that gets rid of the turbidity, suspended solids, and any particulates that causes the water to be turbid. At the end, again, like what we said, we need to get rid of that total suspended solids, TSS. Now, we in the first session, we talked about the TDS. There's a difference between the TSS and the TDS. TDS means total dissolved solids. TSS means total suspended solids. And there's a difference between dissolved and suspended. Suspended means you can remove with filtration, conventional filtration. Dissolved, you need an extra energy to force the water to go with the membranes, or the semi-permeable membrane, which is the reverse osmosis. So, again, like in the first session, we said that reverse osmosis is good, or it's an expensive device that you want to utilize it only for like desalination or like lowering the dissolved minerals in the water to be removed. So you don't want to use it for just conventional filtration. It's a bad engineering feature for that. It's expensive. So now we're going to talk about filtration, and this is a very good subject because the filtration is a good pre-treatment for the reverse osmosis. So we want to talk about multimedia filters, and then we're going to talk about the green sand filters, carbon filters. So this is the simple flow diagram that we showed before. So we're going to take media filter, carbon filter, and we're going to talk about in a brief about the green sand filter. So usually any media filtration, when we say media filtration, the media itself could be different. So it could be multi-layer or multimedia, it could be carbon, it could be green sand, could be ag. So it depends on the media itself that's going to do the job. So generally, the filter would look a cylindrical tank like this. The water would come from the top and leave from the bottom. In a general term, we call this one as a service in. And this is the service out. Okay, so water comes in, goes inside the tank with the media, different media, then it goes out. So usually we have in the bottom screen. So those are different bottom screen. Usually we call them either laterals that are very fine pipes that has very small holes to prevent the sand from coming out, or the bottom distributor. And then here we have something called the upper distributor that's distribute the water uniform among all the surface area. Now at the bottom here, we have gravel. Now it depends on the size of the tank. If it's a small tank, one size of gravel is enough. If it's a medium size, maybe two sizes of gravel is enough, two different sizes. In the big systems or the big filters, we usually use the three different sizes. We use the coarse, the medium, and the fine. Anytime we talk about fine gravel, it's about 1/4 inch size. If it's a medium, it's about 3/8. If it's the coarse, which is the big one, it's about 1/2 inch, average size. So usually it depends on the tank size, like we said. So we might have three different gravel sizes. Then we have a filtration bed, and then we have a supported bed. So that's the filtration bed. So I'm going to talk here about the multimedia or the dual layer. Depends on the application. Usually we have the gravel, and then here we have the anthracite. So this is the anthracite. This is the filtration bed, and that's the underbedding, which is the gravel, at the bottom of the tank. Some people would ask, why do we need to use different layers like this? Okay, now from the name, this is the filtration bed. So basically, that's what is going to do the filtration itself. When the water gets to the tank, it will be distributed throughout the tank. First area that's going to receive the water is the anthracite. The anthracite size is bigger than the sand, of course. The anthracite is like a black color. It's a carbon, but it's not activated. It's not non-activated carbon. So what it does, it doesn't take any chlorine. It doesn't take. It doesn't absorb. It doesn't doesn't absorb any color or remove any odor or whatever like the carbon. So the benefit of having the anthracite here. So when the water gets to the tank, it doesn't hit the filtration bed immediately. So it gets distributed uniformly through the anthracite media. That's the first benefit. The second benefit of this anthracite, although it's not really heavy, but it pushes, makes a weight on the filtration bed. It makes this filtration bed more compact, better filtration. That's the second benefit. The third benefit, which is in my opinion the most important thing, is anytime you start and stop the filter, the first shock that the water, when it gets to the tank, it gets hit by the anthracite. It doesn't get hit by the filtration bed. Usually when the water comes here, start penetrating here, isn't it? So that's the upper layer of the filtration bed. That's what it takes the most load, the dirt load. So let's assume now this filtration is like about 30% of its life before we do the backwash. So you can have some turbidity or suspended solids here. We stop the filter because customers are using it or whatever. So what are we gonna do if we start the system? There's gonna be something called turbulence, isn't it? Water is gonna be moving and whatever. So it's gonna create cloud, turbulence. So the anthracite would prevent something like this. Because by the time that the water gets to the filtration bed, the anthracite will be acting as a shock absorber. It's going to be absorbing all this hammering and all this. So those are the three benefits of the anthracite. The second thing, after the water goes to the filtration bed, like what we already compacted right now. Now, most of the people, they use like the standard number 20 here, which is like a fine filtration bed. It does a good filtration. It will filter suspended solids. It will filter like particulates, turbidity. The good thing about the media filter is we call it depth filter. About 30-inch depth here. I mean, the minimum should be 24-inch. It removes the very, very fine particulates. That's what we call it in the water treatment in definitions, silt. The silt is like when you see in a river that has a very fine, like little mud, very fine, you can't even see it sometimes. This is really, really difficult to remove it with the cartridge filter. You can't. This requires something like the medium depth filter. Those are really good stuff to remove the silt. Now, in the reverse osmosis, we usually like have a limitation of the STI, the silt density index. It has to be lower than 3. And the only way to do something like this, if there is a silt in the water, high silt definition, we need to have a media filter. Again, if the water is oxidized, this is also a good solution to remove like a few amounts of iron, manganese. It removes turbidity, suspended solids, like what we said. So this is the main benefit of having like the media filter or the dual layer or multimedia filters in the water. Now, if the water is really, really, really horrible in the process that we are doing, there is something we call multimedia filter. We can add a couple of layers of garnet. The garnet is like a crushed garnet. It's a good filtration media, and we use it in some special cases, and that's when we call it multimedia filter. Okay, so this is again, anthracite is an unactivated carbon filtration bed, and the different layers we grab off. Now, you can ask me a question. Okay, after a few hours or after 2-3 days, depends on how turbid is the water. How are we going to clean it? So simple. when we say like it's an automatic media filter, regardless of what's in the media inside. So we have the service in like this, and we have the service out like this. Now, if you're going to do the backwash, so bring water from here. So that's what we call it, backwash. In. And that's going to be a backwash out. Now, we usually have a valve here, we have a valve here, we have a valve here, we have a valve here. Now, when we have a service process going on, service in, service out, those two valves are open. This is a close, this is a close. And then we have the rinse. The rinse process is the one that happens after the backwash. That means when you're doing the backwash, the water is going to come from here. So this is closed, this is closed, this is on, open. So everything is going reversal. So now it's time, tank is clean. So we're going to put it back to the service. No, we don't want to put it. Now this is good design if you're going to use the media filter for like non like drinking water application. So if you want to use it for pool water, 4 valves are enough. No need for 5th valve. The 5th valve is called rinse valve. That means in the case of when we're going to do rinse, which is right after the backwash, we open this valve, so we still feed the water from here. This is going to be closed. This is going to be closed. This is going to be closed. Then we need another one from here, goes to the drain. And we call it rinse out. Yeah? So we're going to have a valve here. That's why in the media filters, we have 5 valves. I want to show you like how it looks like. Like this is an example of a filter. It has 1, 2, 3, 4, 5 valves. And so service in, service out, backwash in, service in, backwash out, backwash in, service out, and the rinse out. That's why we have 5 different valves. Now somebody would come and ask, who's going to determine when do we need to do a cleaning or a backwash for the filter? This is a good question. Because what's the benefit of having a media filter if after 1 or 2 days the filter is clogged and it's full of suspended solid or something, but it doesn't do any good? Actually, it's going to be worse than having a filter. Okay, there are 2 ways of doing something like this. Of course, you can have a pressure gauge here, and you can have a pressure gauge here. Anytime there is a difference of pressure between here, and that's what we call the differential pressure. If it exceeds about 1 bar or about, say, 15 psi, I mean, we would always do it at 12 psi. Some people, they would do it at 10. Some people, they would do it at 15. So the bottom line, you don't want to exceed more than 15 psi. If there is a difference between here and here, about 12 to 15 psi, it's time to do a backwash. That means this is fully loaded with derivatives. Now, how do you want to do something like this? There are 2 ways, 2 major ways to do something like this. You can do it through time initiation, like we have a timer, okay? After you monitor the project for 2, 3, 4, 5 days, so you would know, you get yourself familiarized with the water quality. Oh, I need to do a backwash on a daily basis. Usually the backwash is about 10, 15 minutes maximum. So it's not really, you're not going to stop the process for a long time. You can do it at night. You can do it when the factory or the manufacturing facilities is off duty. There's another way that you do it, which is the most professional way to do. You would do something called differential pressure switch. And usually the differential pressure switch and the gauge, they would look something like this. That's the one we're talking about. It's a gauge, and it's switched at the same time. The gauge would allow you to monitor your pressure to make sure that the filter is working properly. That switch would have an inlet called the inlet pressure, and would have an outlet called the outlet pressure. In these cases, the inlet is going to be higher pressure, and the outlet is going to be lower pressure, because when the filter is clogging, the pressure is going to be lower. So that device would trigger, is programmed or is set at, like, let's say 12 psi. So whenever it triggers the 12 psi, it gives a signal to the controller or a stager or a PLC. It's time to do a backwash, and starts immediately. Now that control panel or that stager will send a signal to the backwash pump. So whenever it sends a signal to the backwash pump, before it sends it like in a few seconds, it changes the valve mechanism. Example, close this, open this, open this, close this, close this. That means the water is going to come from here, goes, penetrate the media, take any dirts, and take it to the drain. When we design the media filtration process, we always leave about 35% free space here. Why? We consider that the water, when it's going inside for the backwash, is going to lift up the media. So we don't want the media to start going out of the drain from the top manifold. So that's what we call the expansion space, or the freeboard that we have. So that's a quick explanation about the media filters, and that applies on all the different medias, whether it's carbon, whether it's a green sand, or whether it's ag, or any different media. I'm gonna do some modification here about that. In case for activated carbon filter, so the whole thing here is going to be activated carbon. Pure Aqua, from our experience, the carbon media that we use, which is usually simple with AC, activated carbon media, we use the coconut washed carbon, which is, like from our experience, is a very good media, clean, and it's acid washed. So it doesn't have a lot of debris. So it's clean, nice, it does the job, and it's a little bit more expensive, but it's a good quality. So the benefits of having an activated carbon, like general coconut and good ones, takes organics, takes the chlorine, takes bad odor, smells, and you name it. So whatever, like in the water, it's a very good media to get rid of those things in the water. Do we need to backwash the carbon filter? Yes, you do. But I mean, you don't need to do it like the media filter. Again, the carbon filter is not designed to remove suspended solid. The carbon filter is a good media to the specific things that we mentioned, like organic, chlorine, bad taste, smells, odor, and all those things. So, now, how often do you want to backwash the carbon filter? It depends. Like if like some people, like they don't even have a media filter before that. If you are using the carbon filter to do both like filtration and chlorine absorption at the same time, which I don't recommend, you need to do maybe like once a week or maybe twice a week. If the water that's coming to the carbon filter clean, and just you want to do specific tasks like getting rid of the chlorine, I would do it like every 3 weeks, 2 weeks, maybe 4 weeks. It depends on that. Because every time you do backwash, you're gonna break the carbon granule itself. And every time you break it, you're making it like less efficient. Okay? Now I always recommend in any media filter, whether it's a carbon or it's a multimedia, to have a few things like not only the automation process, to have the pressure gauges before and after, and you should have, if the tank is a fiberglass, you need to have a vacuum breaker. Something happens, You don't want to damage the tank. You also need to have like a pressure relief valve on the top. Whenever you start the tank, you need to replace the air inside the tank with water because the tank is empty. So you want to start it now. When you first receive your product, you want to make sure before you load the media, you want to make sure that the internals are not damaged. Sometimes it happens because of the shipping. You want to make sure that everything's secure, and you want to make sure there is no damage inside. When you want to start loading the media, I would always recommend to fill the laterals inside or the bottom distributor with water, about 3-4 inches higher than the. When you lift the media and start dumping it inside, you want to start with the gravel. So you want to start with the media in the bottom. And you have to be careful, especially in the first few bags. Because until you cover, we said like you want to cover it with water to absorb the shocks first. But still you have to be really careful, especially in the first few bags, so you make sure that the laterals or the bottom distributor is not damaged. Then you're going to start loading after that, the carbon in this case. When you first or initially start the filter, first time you're going to do more than one time backwash to make sure that the media is clean. I would start doing like 3 times backwash. Every time is about 10 minutes. Because only initially the media needs to be washed and clean. I think I covered most of the subjects about the carbon. Now, again, if we're going to talk about the manganese green sand, I mean, from the name, manganese green sand, it's iron and manganese removal. The reason why they call it green sand, it's not green. I don't know why they initially called it green sand. Maybe initially, when the first green sand was invented, it was green. But personally, I really don't know why it's called green sand. If you look at it, it's a black color. So now, the green sand, it's a very efficient media, honestly, to remove high levels of iron and manganese. Now, whenever we size the green sand, that's going to be the green sand. We put layer of anthracite here. So whenever we design the iron removal filter, we need to know a lot of information. So this is not just like a standard filtration. So we need to know what's in the water. We need to know the amount of iron. We need to know the amount of the manganese, sulfates. We need to know the hardness. We need to know the TDS. So we can do a good selection. How many cubic foot of green sand we need to add. Velocity. How many gallons per minute per square foot. Now, the water that goes has to be chlorinated. There are 2 types or 2 different ways to activate or to reactivate the media. First one, you can do it continuous chlorine, which depends how high is the iron in the water, whether it's a 1 ppm or whatever. It's going to oxidize the iron, and the green sand will capture it. And then with the backwash, when you do the backwash, it's going to go to the drain. We're talking about iron and manganese. The manganese is way stronger than the iron. It's like double the. I don't want to say that. It's like really, really nastier than the iron. Very nasty. Now, strong. So when we do even the iron load, we assume that double the strength. The manganese will double the strength of the iron. So whenever you have half a ppm of manganese, it's like 1 ppm of iron. It's very, very nasty. The other way to activate that media again is through potassium permanganate, KMnO4. So you can do that intermittently. You don't need to dose it continuously. Like whenever you start the tank to do a backwash, first you can start doing the KMnO4 dosing, and that's gonna reactivate that media. Again, the green sand media is a good media to handle high loads up to 7, 8, 9, 10 ppm, no problem. But the higher the iron and the manganese, the higher chlorine you need to dose. Because again, the chlorine is going to interact with this media and is gonna like oxidize it. And to do that, the minute you start adding a lot of iron and manganese, you're gonna have a lot of chlorine in the water. Sometimes you need to dose maybe up to 20 ppm of chlorine, which is really high.
That's high.
Yeah, it's really high. So it depends. I'm being like giving like high examples because just to show you that this is a good media to remove the iron and the manganese. Okay, and it's a good solution to act as a pre-treatment for a lot of different processes, including reverse osmosis, including ion exchange like softener, including protecting a lot of pipe networks, car wash, washing for like whether it's like appliances, car wash, airplane wash. So you can like use it in a lot of different applications. I think I covered other medias like besides the iron and manganese, green sand. There is an ag filter. The ag is a lighter media that's similar to the multimedia, but I mean it's designed to reduce the suspended solids and the temperature in the water. So this is good when you don't want to spend a lot of water in the backwash. The backwash rate for it is a little bit less, so you would save a little bit of water in the backwash process. Now, what else we have to cover here? Yeah, let's talk a little bit about the tank itself, which is the one I'm drawing here.
Yeah, how large are those?
Oh, the question is like how large are those tanks? They can be as small as 7-inch diameter. We do it up to 144-inch diameter. Now we always prefer tanks that has straight height. When we say straight height, this is the dome, like this, and this is another dome, and then from here to here is we call it SH or the straight height. And we prefer like minimum of 60-inch. The reason why we came up with 60-inch because it's about 5 feet. Because like what I said, here we need about 24 inch. So we need to consider some room for the expansion.
Yeah.
3-bed when we do the backwash. Now, those tanks, we do them either stainless steel, like a lot of different industries, like beverage industries, pharmaceutical, they prefer stainless steel, or we can do fiberglass, like our NF600 series, something like this, or we can do them in we can do with steel tanks like this, something like this. They can be epoxy coated from the side, or we can do them in stainless steel like this. So we have 3 different types of tanks. They can be epoxy coated steel, or they come stainless steel. The stainless steel could be 304 or 316, or the last type, which is fiberglass. Now, for seawater applications, if the whatever you're filtering here is seawater, I would definitely go with fiberglass. If we are filtering water that has high chlorine, I would never go with the stainless steel, honestly, because we know that chloride is the first enemy for the stainless steel. You're going to start having a lot of problems with the stainless steel. I would also go for, like, it depends on the industry. Like beverage industry, they always like stainless steel. In cases like this, we would do like some special lining for them, like glass line or some special coating inside, because they would do something called steam sterilization with the carbon filtration. Now, this one, like having valve mechanism like this, for a smaller filter, like what we said, 7-inch, like 7-inch to 24-inch, we can do like a single valve that do all those 5 valves, 5 different processes in a way where it's easier to do it in a top-mounted valve.
So, Maher, in relation to this equipment that we're talking about, what is the size that is recommended in relation to this? Because we need this as part of the
Correct.
system, right?
No, that comes included in the system.
Oh, yeah. So what size is recommended for this size?
I'll draw it for you now. Now, that's the last type, which is the top-mounted valve that we talked about. That valve here, it does the job for all those 5 different valves. But this is only good for the small systems, like the one we are talking about.
I see.
Okay. Now, we're gonna like finish talking about the filters. Thank you again. So we'll go on to the next session after we finish.
Okay.